Alright, here's just a little video on graphing polar. Some of us are having a little bit of a hard time graphing our polar graphs, so I'm just going to go over the basics with you. Let's take a look at the very first one. We're going to take a look at graphing 4 cosine theta. Okay, so the first thing that I would do is actually graph the Cartesian equation for 4 cosine theta. We know the amplitude is 4. And the period is normal. The Cartesian period is normal. So we would go out to 2 pi. Cosine starts up and then goes down and then comes back up. Okay. So what I'm going to do, this is my theta and these are my r values. I'm going to go over here to my polar grid and here's my angle measure 0. I'm going to plot a point at 4. Okay, so angle measure 0, we're at 4. Then at angle measure pi over 2, and this is pi over 2, we're back at 0. So, and we want to make the graphs kind of plump looking. We go down to pi and we're at negative 4. So here's pi, but I'm negative 4, so that shoots me across over here. And basically I'm able to finish this particular circle in just pi. Just pi radians is all it takes. So that's just a 4 cosine. Like if it was 3 cosine, it would be a circle, you know, at 3. You know, 2 cosine would be a circle at 2, and so forth. That's where the circles would be. So there's a whole family of 4 cosine, you know, those cosine graphs create circles. And you just need pi to create the circle, that many radians. Alright, so let's go and let's look at a different kind. Okay, so let's move that one out of the way. Let's look at these. Okay. So let's look at 1 minus 4 cosine. Okay, so let's work on the Cartesian graph. So this 1 tells me that I'm up 4. Excuse me, the 1 tells me that I'm up 1. My sinusoidal axis is up 1. And then the 4 tells me the amplitude. So I need to be 4 up and 4 down. Okay, and the cosine is negative, so I've got to, I have a little bit of a different pattern. So our period, normal period, is the same. So with the negative cosine, so this is my sinusoidal axis, with the negative cosine I'm actually going to start down instead of starting up. So I start down here at my lower value. And then we're going to move up. So then we have here, 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 and here. Okay, so it looks kind of like that. Alright, so at angle measure 0, we're actually at a negative 3, which puts us right here. So this is angle measure 0, but we're at a negative 3, so we're over here. At angle measure pi over 2, we're at, so here's pi over 2, we're at a positive 1. So we're right here. At angle measure pi, we are at 5. So let's figure this out. So we start at 0. And this is a first quadrant angle, so this is my first quadrant right here. But I'm negative, so I'm actually going to be across over here. This is where I'm going to be. So I'm starting at a 3, and then I'm inside of this quadrant right here. Right here. And then we go through 0. Let's get a little space over here. Okay, so we're at 3. Right here we go through 0. And we go up. So we're 3. We are in the opposite quadrant, so we're down here. We go through 0, and then we go up to a 1. So we're in here. So then at pi, we were at 5. 1, 2, 3, 4, 5, we're here. So that brings us around here. Then at, where are we? 3 pi over 2, we're at 1. So here's 3 pi over 2. We're at 1. So we're here. Then we're going to cross through the pole. That's where, okay, right here is where we're crossing through the pole. Those are the locations we cross through the pole. So we're going to cross through the pole, and we're going to go, so for 2 pi, we're going to be at a negative 3. So 2 pi is back over here, and we're going to be at a negative 3. So that puts us right here. So what we have is we have a circle inside of a circle. It's kind of a loop. And where does the loop start and stop? That's a pretty important information for us. Where does it start and stop? So, you know, we had the inner loop when we went in the negatives, when r was negative. That's where we had the inner loop. Okay, so we actually were at this piece of the inner loop at a negative 3. Okay, so we have a little bit of a weird thing going on. Let's kind of highlight that. So here we are. This is the inner loop from negative 3 to 0. So we're over here at negative 3. And we're going to 0. That's this piece. So from 0 to pi over 2, this is what we have, that part. Now let's look at here from 0 to 2 pi. So here's 0, and again 2 pi is over here, and this part is in the 4th quadrant. So 0, from 0 to 2 pi is this right here. This is 0 to 2 pi. So our angle measures, what we would have to do to find these zeros right here, and this is a fairly complex problem, to find those zeros we would have to set our equation equal to 0, and then we'd have to solve. We have to figure that out. So this is not going to be a unit circle value, so this would be a calculator problem. We'd move the 1 over, then we divide by 4, so we get 1/4 equals cosine, which is not a unit circle value, so we would use our calculator to determine these starting and stopping points. Actually, it's basically this one's kind of cut in half. We have 2 pieces of the inner loop. Okay, well that was super fun. Let's try another one. Let's do one more, like with the loop thing going on. Let's see what causes those. Alright, so we have our amplitude is up 2, our sinusoidal axis is up 2, and our amplitude is 4. Okay, so our sinusoidal axis would be up 2, and our amplitude is 4. So we go 4 above and 4 below. Okay, this is our, pi and 2 pi, theta and r. Okay, so it's sine. So sine starts at the sinusoidal axis and then goes up and then down. So it looks something like this. Alright, so let's work it over here. So at angle measure 0, we're at 2. Okay. Then here's pi over 2. At angle measure pi over 2, we are at 2, 3, 4, 5, at 6. So we're up here. So we make a loop around like that. At angle measure pi, we're back at 2. Then here we get to have fun. We get to go negative. So at angle measure 3 pi over 2, which is this location, we're at a negative 2. So that means that we are up here at a negative 2. So we go up here, and then we're going to come back out. So the starting and stopping of that loop, that same kind of concept, is where an R is 0. It's here and here. Unfortunately, we can't really read it off the graph, or we would have to solve the equation. Right, we would say 0 equals 2 plus 4 sine theta, and we have to work that out. So negative 2 fourths equals sine. So we want to know where sine is negative 1/2. Those are the locations we'd be looking at where sine is negative 1/2, which of course would be down here and here. So what? 7 pi over 6 and 11 pi over 6. Okay. So let's do just a couple more, then we'll call it a day. Okay, so we finished with that one. Let's do some flowers. Okay, so this one, the 4 tells us the petals are 4 rings long, and the 3 tells us there should be 3 petals. That's what that tells us. So we know from our Cartesian experience that the period equals 2 pi over b. b happens to be 3. So the period, the normal period of this would be 2 pi over 3. Alright. So our amplitude is 4. And our normal period is 2 pi over 3. So that means that's pi over 3. So cosine starts up, then goes to the middle, goes to the middle, then goes down, middle, up. So it would look something like this. Okay. So at angle measure 0, we're at 4. Now these points right here, these tips, are the ends of the flowers. They're the ends of the flowers. If I kept going, I would get my, flower. So this is one petal, and this is another petal. So really all we need to know is where are the ends of the flowers. So I have an end of a flower at pi over 3. Actually, so let's do this first one. I have one end of a flower at right here at 0. So I know I've got a petal there. Alright, this one is a negative 4. It's a negative 4. That's so we're at pi over 3, but it's a negative 4. So pi over 3 would be what, around here, right? But we're at a negative 4, so we're going to be over here. 1, 2, 3, 4. Okay, and then at 2 pi over 3, we're at 4. So let's see, 2 pi over 3 would be right over here. 1, 2, 3. Put us right here. So that's what our flower would look like. When do I have a petal starting and stopping? Well, it's going to start and stop, where it crosses this axis. If I can't tell where it is on my graph, I mean, we can see there it crosses, you know, right on that x-axis, or the theta axis, if you will. This first location is going to be pi over 6, and this second one, so 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, right? So 3 pi over 6, which is pi over 2. So this petal, one of the petals, starts at pi over 6 and ends at pi over 2. So if we were integrating the area of one, we would just go from pi over 6 to pi over 2. That would give us one petal. Those would be our bounds. And we found that from this graph right here. Alright, last one, I'll just kind of outline it just a little bit. Let's look at one with even petals. So this one, we have a petal length of 5, and this is 2 theta, so that means that there are 4 petals. That's just what that means. We double that number, so there's 4 petals. So let's see where they lie. So 5 and negative 5. So we know that our period, 2 pi over b, so 2 pi over 2, so the period is just pi for one period. Let's just go with one period and see what happens. Which that would be pi over 2, and then there we go. So we start up, because that's what we do with cosine, then go the middle, down, middle, up. Alright, so we would start at angle measure 0, we're going to be out at 5. So I have a petal here. Okay. Then at angle measure, so here's a petal right here, it's one full petal. Angle measure pi over 2, I have a petal right here. And at angle measure pi, I would have another petal. I'd have to continue my Cartesian graph if I wanted to do that. I have another petal. So 1, 2, 3, 4, 5. Now you can probably see the pattern now. And really, if we wanted to find the area of one petal, we would just need one start and stop. I'd probably pick here to here. If this is pi over 2, then right, halfway between 0 and pi over 2, this would be pi over 4, right? And then this one, halfway between pi over 2 and pi, would be 3 pi over 4. So if I was integrating one petal, I could go from pi over 4 to 3 pi over 4. Those would be my bounds. Alright, hopefully that helps.